Good morning or good afternoon, algebra kids. Today's video is going over slope-intercept form and all that you will use slope-intercept for in terms of finding slope, finding y-intercept, graphing, given a table, putting it into slope-intercept form. There are a lot of different ways to use slope-intercept form. So I'm going to quickly go over some notes. I'll go over a couple practice problems, but the rest is on you, okay? Here's the game plan. You have Tuesday and Thursday to get this done in class. Friday, I am going to check your math notebook for every single practice problem, okay? So you have no time to be goofing around in class. You have no time to be chit-chatting. You have no time to waste. Okay, you can discuss in groups over math work. Okay, the substitute knows what's going on. I've left him very detailed explanations. I expect leaders in all of my algebra classes, ones who are doing very well in class, to keep the class in check. Because one, you will be losing points, severely losing points. Okay, if I come back Friday and a student hasn't done their work, it is a 0 in the grade book, which is 500 points off the team score, and it is also 200 points off because you didn't do what you were supposed to be doing. Okay, I'm trying to prepare you for the test. I am taking time out of my day to make videos for you guys to prepare you for the test. I'm not going to be here Tuesday, Wednesday, and Thursday. I decided instead of book work, I would post everything you need for the test. I would make sure to do videos so that you guys could look at and listen to me as I explain things. And if you have any questions, if you have any comments, you can post it in YouTube. You can post it in Google Classroom. You can email me. I will be at workshop all day tomorrow, Wednesday, and Thursday, but I am more than willing to catch a quick glance at an email and quickly respond, or wait until I get home and quickly respond. Okay? I am doing my best to make you guys ready for next week. Everything is there. But I'm going to be checking for notes. I'm going to be checking to make sure every single practice problem is completed. It is okay if you started a problem, you tried it, and you couldn't figure it out. I would rather have that than nothing at all. Because if I'm going to spend time making videos for you guys, you better be paying attention to them and you better be doing the work, or else I will not do this. I enjoy doing stuff for you guys. I enjoy having a good time with you guys, but you are here to learn, and I'm here to prepare you for college. Okay, without further ado, let's get started. Okay, slope-intercept form. Y equals mx plus b. M is the slope, b is the y-intercept. So let's look at examples. Okay, this first one, y equals 2x minus 4. 2 is your slope. -4 is your y-intercept. So if on a test it asks you to identify the slope and the y-intercept, all you do is write 2, -4, you're done. B tries to trick you up a little bit. It flips the x-intercept and it flips the slope. But if it is being attached to x, it is slope. If nothing is attached to x, that is your constant, that is your y-intercept. So slope here is -1/3. Your y-intercept is 1. C is in a different form. It's in another form called standard form. And you can go between standard form and y-intercept form and y-intercept form and standard form. Or sorry, slope-intercept form and standard form and standard form and slope-intercept form. I apologize. I did not mean to confuse you. Okay? But we want it in slope-intercept form. So, literal equations from Unit 1. Here's an extension on it. You're solving for y. So we subtract 3x from both sides. Y is -3x plus 5. And now we have our slope and we have our y-intercept. Okay, last one. Before we put this into slope-intercept form, we can actually get the y-intercept and we can get the x-intercept if they asked you for the x-intercept. Okay? In standard form, you can find the x and the y-intercept really quickly. Okay? Let me show you. I'm covering up 4x because I'm saying x is 0, and 4 times 0 is 0. Now, what do I need to multiply -8 by to give me -24? In your head, if you said 3, you're correct. So the y-intercept is 3. If it asked you for the x-intercept, if a problem asks you for the x-intercept, you say, okay, well now y is 0. -8 times 0 is 0. What do I need to multiply by 4 to give me -24? If you said in your head -6, you're correct. Okay? But that is if they ask for the x-intercept. So let's go ahead and change this into slope-intercept form. So let's subtract 4x from both sides. So -8y equals -4x minus 24. Then we divide both sides by -8. So 1/2 x plus 3. That is the equation of my line. And notice the y-intercept is 3. And my slope is 1/2. Question. When using slope-intercept form to graph a line, it helps to have the slope in fraction form. How can you rewrite an integer slope as a fraction? Let's do a couple examples on here. So if my slope is 6, how do I write that integer as a fraction? And you've seen me do this. When we have a fraction and we multiply by an integer, I put a number in a specific location. It's usually underneath the integer. Okay? It's the number 1. Here's one other quick example. So if the slope was -7, I would write -7 over 1. So how can you rewrite an integer slope as a fraction? You just add on 1 in the denominator, and you keep the integer in the numerator. Second question. Sometimes a linear equation does not have its slope and y-intercept values clearly visible. What is the y-intercept for the line y equals 3x? Well, so clearly my slope is 3. And there is actually a y-intercept here. It's not visible, but it's 0. Now, if you were to put y equals 3x plus 0 on a quiz, on a test, I would not count it wrong because you're telling me the y-intercept is 0. We usually don't do it because we don't need to. So we just erase it. Now notice here, if our y-intercept is 0, what do I multiply by 3 to give me 0? 0. So this line actually goes through the point 0, 0, which is indeed the origin. And as we talked about previously, if it goes through the origin and has no y-intercept, it is direct variation. And we will go into more detail on direct variation in another video. And there will be lots of practice problems in that regard. I am going to go ahead and move on to the worksheet, but you're more than welcome to pause the video right here, finish up any notes you have, go over any notes you have, but I'm going to go ahead and move on to the worksheet. Okay, so for the first three, you're identifying the slope and the y-intercept of each, and you're graphing. Okay, so what does that look like? Let me do number one for you. So this is in standard form. I want it in slope-intercept form. So we need to solve for y. So let's add x to both sides. We have 2y equals x plus 6. Divide both sides by 2. Y is 1/2 x plus 3. So this is the equation of the line, and we can easily see that the slope is 1/2, the y-intercept is 3. So I can graph it. Here's 3. And remember, it's rise over run. So I'm going to run 2 to the right, and then I'm going to rise 1 up. So write 2 up 1, write 2 up 1, write 2 up 1, write 2 up 1. And then the other way, I'm going to go down 1 and left 2. I go the opposite. Down 1, left 2. Down 1, left 2. Down 1, left 2. And then to the best of my ability, I will connect the dots. And there's my line for 1/2 x plus 3. That is what you need to do for 2 and 3. Okay, I'm going to move on to 4, 5, and 6. You can pause the video here if you wish. Okay, now it says using the given information, write each in slope-intercept form, then graph. So slope-intercept form. Whenever you see a slope-intercept form, get into the habit of writing y equals mx plus b. Slope is -3, y-intercept is -1. That goes in for m, that goes in for b, respectively. So y is -3x minus 1. I can graph it. So here's -1. And I'm going to go, and here's where, when they ask that question about how do you change an integer into fraction form, you just add the 1 in the denominator. So my rise over my run, I'm going to go down 3 and to the right 1. 3 and to the right 1. And then the opposite would be left 1 and up 3. Left 1 and up 3. And then I connect, and there's my line. Now, how do you know which way the slopes go, which one's positive, which one's negative? So here's a quick trick, which I literally just came up with, okay? When you dab, personally from your perspective, when you dab, positive dab, negative dab. One more time, positive dab, negative dab, okay? So if that is too confusing for you, you can go back to the traditional slope dude or slope man to help you. But that is how you can distinguish between positive and negative slope. So this is number 6. You'll need to do 4 and 5. Again, you can pause the video here, or you can keep watching. Okay, here they give you the line, and they want you to write the equation. So you're going to do something similar to number 5 on the quiz, or those extra tutorial problems where you need to write the equation of a line given 2 points. Well, how do you find the 2 points? Let me show you. Doing question number 8 here. The graph intersects here. The graph intersects here. This coordinate is 0, 4. This coordinate is 2, 1. I have 2 points. I can get the slope. So if I want to end up having it in slope-intercept form, y equals mx plus b, okay, and I need to know slope formula. Slope formula is y2 minus y1 over x2 minus x1. y2, 1 minus y1, 4. over x2, which is 2, and x1, which is 0. So my slope is -3/2. And you can actually check, because you have the graph, you can actually check by going left 2 and up 3. And so you could get, theoretically, you could get another point if you go the other way. You go down 3 and to the right 2. So this is the correct slope. Now, you have slope, but you don't have the y-intercept. How are you going to get the y-intercept? You pick either 0, 4, or 2, 1, and you plug it in. I'm going to pick 0, 4 because I'm replacing x with 0, which means I will replace y with 4. -3/2 times 0 is 0. So this whole thing is gone. And so b is 4. So the equation of my line is 1/2 x plus 4. Or sorry, -3/2 x plus 4. Okay, so we can write here y equals -3/2 x plus 4. Okay, you're welcome to pause the video here. But I'm going to move on. Okay, this is the last part, or second to last part. I'm not going to do 10 or 11 because that is from question 1 on the quiz, as well as the tutorial extra problems. You just pick 2 points, you get the slope, you pick 1 point, you get the y-intercept, and then you graph it. So I'm not going to go over one of those. But what I will do is quickly discuss number 16. Number 16 is a special graph. Okay. If x is 1, what is y? 1. If x is 2, what is y? 2. If x is 0, what is y? 0. If x is 1,000,000, what's y? 1,000,000. So this has a slope of 1, and so the rise is 1 and the run is 1. So I go right 1, up 1, right 1, up 1, right 1, up run, right 1, up run, right 1, up 1. So all these points here are all from y equals x. And you can go the same, and it'll be the same thing but the other way. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. So if I connect the dots, this is the equation y equals x. Okay, this is a special graph. It has a special name. 16 is called a parent function. Okay, the reason why it's called a parent function is pretty self-explanatory. It is the starting point for all your linear functions. This is where you start. You start with y equals x. Okay, if you add on a y-intercept, you're shifting the graph up or you're shifting the graph down. If you add on, in the example of 15, you're adding on a coefficient 4, that means I'm taking this and I'm multiplying all my values by 4. So what happens to my graph? You could probably see it will go from this standard, and then it will get closer to the y-axis. It will be a lot steeper. If my values are less than 1, so my graph goes like this, it will start getting smaller and it'll get closer to the x-axis. There is a unit that we will reach later on, not in this unit, but probably in the next couple of units, about transformations. Okay, this is your starting point. Whatever you add on to it, you are transforming the graph. So that is why y equals x is the parent function. It is the starting point for all your linear functions. And you'll see it for other ones. When we get to quadratics, there's a parent function for quadratics. If we get to cubics, there's a parent function for cubics. When we get to exponentials, there's a parent function for exponentials. Okay, so this is solely day 5. This is the video for day 5. Okay, you have 17 problems to do. I should see 17 problems solved. If you did any extra problems in the notes, add them on. I'm perfectly fine with that. Okay, but there will be a video for day 6. There will be a video for day 7. There will be a video for day 8. So at least 3 more videos. Okay, and then you should be good to go, and you should be able to finish everything and be ready to do the test review. Okay, so good luck. You have your friends, you have your classmates to ask questions. You can email me, you can post a message in Google Classroom, and you can post a comment for this YouTube video. Okay, best of luck to you guys.